Hi everyone, welcome back to Tech-Bimba channel. In the previous video, I have talked about wait, notify, and notify all methods, how these are being used to solve the producer-consumer problem, how these are being used in the inter-thread communication. In the today's video, I will dive into blocking queue. Before looking into the blocking queue, it is important to understand the challenges of using the wait, notify all methods. The main challenge is we have to code very carefully, otherwise we hit with issues like a deadlock, missed notification, infinite wait, spurious wake-up from the OS itself. In the last video, we have seen that in case there is a one producer and more than one consumers are involved, on calling the notify, any of the consumer thread might get a false notification, because of which it will try to consume an element from the shared buffer even though shared buffer won't have any element. To solve this one, we have to always use a loops over if condition. We have seen this in detail, and we have also seen that even though in our code we have called a wait method on a thread and it is in a waiting state, sometimes OS itself will wake up that thread because of some optimization reasons, which causes that waiting thread to come to the runnable state, might cause undesired results in our program. And also we might get a deadlock issues. So let's try to understand what is deadlock. In this diagram, we can see that there are two threads, thread X and a thread Y. Thread X acquired a resource A and it is trying to acquire a resource B to proceed further with its execution. On the other end, there is a thread Y. It acquired a resource B and it is trying to acquire a resource A to proceed further with its execution. But thread X won't be able to get a resource B because it is acquired by thread Y. Thread Y won't get a resource A because it is acquired by thread X. Because of this situation, thread X and thread Y will enter into the infinite waiting or a block state. This is what we call it as a deadlock. To address these issues, in Java 5, Java developers introduced blocking queue. This is how the blocking queue look like. Here we can see that there are two ends, tail end and a head end. Using a tail end, we insert the elements into the blocking queue. From the head end, elements is removed from the blocking queue. Thread 1 is the one that is inserting the element into the blocking queue, so it is a producer thread. Thread 2 and thread 3 are consuming the elements from the blocking queue from the head end, so these are the consumer thread. So the beauty of the blocking queue is here we no need to call wait, notify all method explicitly. All these are internally handled. So in case there is no space available in the blocking queue, producer thread will enter into the blocking state automatically. On the other end, in case there is no elements in the blocking queue, consumer threads will enter into the blocking state automatically. In a real world example where there is a use case of solving a producer consumer problem, we use the blocking queue itself. So we won't be using the wait, notify all methods because of the challenges we have discussed. Now let's try to understand the hierarchy of blocking queue. Blocking queue is introduced in Java 5. It is part of java.util.concurrent package. Blocking queue is an interface that extends the queue interface. Since it is an interface, it is implemented by the classes array blocking queue, linked blocking queue, priority blocking queue, delay queue, synchronous queue. So these are the classes provide the implementation to this blocking interface. Now let's try to understand the methods those are present in the blocking queue. Methods present in the blocking queue can be categorized into 4 categories. The first category is the exception. In this category, there are two methods, add and remove. So on calling the add method, if there is a space available in the blocking queue, the element will be inserted into the blocking queue. In case there is no space available in the blocking queue, on calling the add, it will throw illegal state exception. So in case there are no elements at all in the blocking queue, but we are trying to remove the element from the blocking queue by calling the remove method, then we will get an exception. No element exception is the one we are going to get. In case there are elements, the element that is present at the head end of the blocking queue will be removed. Second category is a special value. So on calling the offer method, if there is a space available in the blocking queue, element will be inserted into the blocking queue, else it will return the false, indicating that element is not inserted into the blocking queue. On calling the poll, in case there are elements, the element present at the head end of the blocking queue will be removed. In case there are no elements, then poll method will return a null value. Peak method will return the element present at the head end of the blocking queue. It won't be removing that one, it is just returning the value that is present at the head end of the queue. Third category is the blocking. So here there are two methods, put and a take. In case there is a space available in the blocking queue, on calling the put, element will be inserted into the blocking queue. In case there is no space available in the blocking queue, on calling the put, producer thread will enter into the blocking state. So then there is a take method. In case there are elements in the blocking queue, on calling the take method, the element present at the head end will be removed. But in case blocking queue is empty, then consumer thread will enter into the blocking state. So these are the methods being used to solve the producer consumer problem. Fourth category is the timed blocking. So here there are two methods, offer and a poll. So these are the overloaded methods of a offer and a poll method. We can see here it is taking an extra parameter as a timeout and a unit. So here we specify the time duration and also we specify the unit, whether it's a seconds, millisecond, that what we specify in the unit. On calling this one, producer thread will wait for the specified duration. Once the specified duration is expired, producer thread will try to insert the element into the blocking queue. In case there is a space available in the blocking queue, element will be inserted into the blocking queue. Otherwise, this method will return a false value, indicating blocking queue is full and element is not inserted into the blocking queue. Second one is the poll. So consumer thread will wait for the specified duration of a time. So after waiting for the specified duration, even though blocking queue is empty, then it will return a null. So after waiting for a specified duration, if there are elements in the blocking queue, then element present at the head end will be removed. Hope this is clear what all the methods are present in the blocking queue. Now let's see in what scenario we have to use which implementation of this blocking queue. The first one is array blocking queue. So internal structure of the array blocking queue is the array. Here, if you know in advance that what is the size of the blocking queue, then array blocking implementation can be used. For example, rate limiting. Say suppose we have a web application and we want to control how many requests we need to serve within a say suppose 10 minutes. In such a use cases, we can use the array blocking queue. One more example is, say suppose we are building a e-commerce website and there are a limited stocks we have and we want to restrict that we can only serve these many orders. In that case, we can use the array blocking queue. So it's a bonded in nature, which means we know the size in advance. Second one is the linked blocking queue. Here the backend internal structure is the linked nodes. It's a dynamic in nature, means continuously request or elements will be arriving into the blocking queue and there are threads. Those will be continuously listening to those blocking queue. Once that elements or request will arrive to the blocking queue, those worker threads will consume that one and they will start processing that one. So we can use the linked blocking queue in case of a thread pool. Say suppose we are having a web server request handling process where the request will come and those requests will be entering into our linked blocking queue and there are a worker thread. So once the request arrives to that linked blocking queue, that worker thread will consume that request and it will proceed with its execution, how to process that, how to serve the response to that particular request. In that case, linked blocking queue is preferred. Third one is a priority blocking queue. So internal data structure, here we use the heap. Okay, so it's unbounded in nature. So here we give the priority to the task. Say suppose to give the real world example, say suppose in a hospital, the patient whose situation is critical, those patients will be treated first. We are basically prioritizing based on the patient condition. In such a cases, we are using the priority blocking queue. Fourth one is a delay queue. So delay queue is a mixture of a priority queue plus a time delay. Here we often say suppose we reset our password, we often get a mail saying that when we need to log into the website after 5 minutes. So here there is a urgency, also there is a time bound also. In such a case we use the delay queue. Last one is a synchronous queue. Here producer thread ensures that whatever the element it has produced is consumed by the consumer thread. So it will happen in the real time. So it is being used in a cached thread pool and where there is a real time processing system, right? In that case we use the synchronous queue. Hope this is clear in what scenario which implementation of the blocking queue we need to use. Now let's see the real world example or a code example of how blocking queue can solve the producer consumer problem. So here we have a class with a name test. We have a public static void main here. We are creating the instance of a blocking queue over here. Then we are having a producer thread and a consumer thread. Producer thread is running a for loop for a 5 times. Within each iteration, we are putting a value inside the queue using the put method. After inserting the value into the queue, right, we are making producer thread to sleep for a 1 second. Okay, before that we are printing the value that is produced by the producer thread. So consumer thread is basically consuming the values present in the queue. So here it's running the while loop, okay, and we are calling the take method. So at the line number 30 we are printing the value that is consumed by the consumer thread. Then we are starting producer thread and a consumer thread. Okay, we'll run this one. Yeah, we can see that producer thread and consumer threads are running in sequence, and we can see that whatever the value produced by the producer thread is consumed by the consumer thread. And we can see that we are not using the wait, notify all method. All this is internally handled by the blocking queue. So if you go to the implementation of the blocking queue, so we can see it is a part of java.util.concurrent package. Okay, this blocking queue is an interface. It is extending the queue interface, and we can even see the documentation of a put method. Okay, if you search a put over here, yeah, we can see the documentation. Insert the specified element into the queue, waiting if necessary for a space to become available. So this put itself will take care of blocking the producer thread in case there is no space available. Similarly, take method retrieves and removes the head of this queue, waiting if necessary until an element becomes available. So it will take care in basically it will make consumer thread to be in a waiting or a block state if there is no elements in the blocking queue. So this is how blocking queue makes developers life easy while solving the producer consumer problem without worrying about explicitly calling wait, notify all method. Okay, in the next video we will see into lock semaphore in detail. If you found this video helpful, please like, share and subscribe to the channel. See you in the next video. Thanks for watching.